In the movie scene from The Outsiders, Ponyboy uses a bottle of hydrogen peroxide from a typical drugstore to dye his hair silver white. Let's take a closer look at this scene and explore the science behind hair bleaching, and answer the question in mind, which is it really possible to achieve such a drastic color change with just hydrogen peroxide?
Peroxide? You ain't
We're
thinking...
gonna cut our hair, Ponyboy. You're gonna bleach yours. They'll have the descriptions in the paper. We can't fit them, man.
No, sir. You ain't gonna touch my hair.
Look, we'd have to anyway if we got caught. You know the first thing the judge does is make you get a haircut.
I don't see why.
I don't either. Guess it's just a way of trying to break us. I'm gonna cut mine off, too.
Here. Gee, this really makes me look tough.
Unfortunately, the transformation shown in the movie isn't too chemically accurate, as hydrogen peroxide alone does not have the properties to cause a drastic change in hair color. So let's use our AP Chemistry superpower and shrink down to the size of atoms to further understand why. This is hair, which consists of 3 layers. The outermost layer is a cuticle. It's like a protective shield made for overlapping cells. It guards the inner layers and helps lock in moisture. This is the middle layer, which is the cortex. It has 2 types of melanin. Eumelanin, which is found in more darker brown and black hair, and pheomelanin, which is found in lighter blonde hair. These are pigments that give your hair its color. The cortex also gives your hair its strength, elasticity, and thickness. Lastly is the medulla. It's the innermost layer and is often absent in finer hair. Its role is mostly structure, so we won't be talking much about it because it doesn't impact bleaching. Well, how does this structure relate to bleaching? Hair bleaching heavily relies on oxidation of the melanin in the cortex layer. This process changes the natural color pigmentation to create a lighter look. However, the hair cuticle limits oxidation results by limiting the amount of hydrogen that can penetrate into the hair cortex. Even with a higher concentration of hydrogen peroxide, the cuticle still acts as a significant barrier. Additionally, the drugstore hydrogen peroxide used would be very unstable when bleaching. Drugstore hydrogen peroxide typically has a concentration of 3% or 0.88 molarity. This would essentially do nothing to Ponyboy's hair. This is because the hydrogen peroxide decomposes into water and oxygen. This reaction is hydrogen peroxide's decomposition. It is thermodynamically favorable at standard room temperatures. When hydrogen peroxide is exposed to the O2 or oxygen in our air, the reaction will shift right in favor of the decomposition. This will just produce water in liquid form and oxygen in gaseous form. Especially in basic conditions or higher pH levels, hydrogen peroxide is favored to decompose. This is a problem. Why, you may ask? Hydrogen peroxide on its own is slightly acidic with a pH around 3 to 6, which isn't too effective at opening the hair cuticle. For allowing the first cuticle layer to open, we need a more basic alkaline environment, which is usually achieved by adding ammonia or baking soda as catalysts, which have a pH greater than 7. This helps the cuticle layer open up, allowing for better penetration of the peroxide to oxidize the cortex layer. In order for Ponyboy's black hair to achieve a platinum white, he would need to use a high concentration of hydrogen peroxide for his bleaching agent, as well as a catalyst such as sodium bicarbonate to alkalinize the pH of his hair's cuticle to open it up for eumelanin oxidation. Not to mention, it would take multiple bleaching sessions for the span of 1 to 2 weeks to achieve such results. This repetitive process would damage your hair, altering its pH, which is normally supposed to be 3.5 to 4.5.